Hello students, welcome back to Tantray physics classes. Today's lecture is on centrifugal force. Centrifugal force. It will be a lecture on a non-inertial frame of reference. Okay, centrifugal force. Centrifugal force. Centrifugal force. What is the origin of this centrifugal force? Where from it comes, and is it a real force or it is a pseudo force that we have to see. First of all, let us go concentrate on the basics. Centrifugal force is not a real force. It does not have a real agent. It is being observed by an observer who is in the non-inertial frame of reference. Kind of a pseudo force it is. A person who is in the non-inertial frame of reference observes that there is a force on the object, and that force he calls a centrifugal force. But the non-inertial frame of reference the non-inertial frame of reference is the rotating frame of reference. After all, rotating frame of reference is also accelerating towards its axis, and therefore that's also a non-inertial frame of reference. And a person in that frame of reference observes that there is a force on the object, and that force he calls as centrifugal force. And this force does not have a real agent. It is being observed by a person in the non-inertial frame of reference as a result of that frame of reference. That's all. So let me write it down. Centrifugal force. Centrifugal force is experienced by or experienced by an observer in rotating frame of reference. Rotating frame of reference. A person in a system which is rotating, if there is an observer, he will feel a force on the objects, maybe inside that rotating frame or maybe outside that rotating frame. He will observe a force on them, and that force we call it centrifugal force. And this person in the rotating frame of reference will also observe acceleration on that object, because if there is a force for him on that object, there must be acceleration also for him on that object. Okay, now to explain the concept, let me take an inertial frame of reference, and let me take at the same time a non-inertial frame of reference, I mean the rotating frame of reference, and let us observe an object within the rotating frame of reference for both the observers. Later I will take the object outside, and again we will make the observation from two frames of reference, inertial frame of reference and rotating frame of reference, and we will mark the observations of both, and then we will understand the things. Okay, you see, it's a cylinder, let me say, it's a cylinder, or a cabin, or maybe it's a compartment, maybe it is a system. It is rotating with angular velocity omega. It is rotating. It is rotating. It is base. It is base of the cabin. It is base of the cabin, and here is a person. Here is a person on the ground whose velocity is 0. It is ground, and he observes an object, and that object is here. That object is here. the mass of the object is m. The mass of the object is m. Let m be the mass of the object. Mass of the object. The object is stationary with respect to the cylinder, rotating cylinder. This is the base of the cylinder. The object is stationary with respect to the cylinder itself. That means it is not rubbing, it is not sliding in the cylinder. It is fixed in the cylinder. It is at rest in the cylinder. Okay. Now, let me ask this person. This person is an observer in the inertial frame of reference. It is inertial frame of reference. Again, inertial frame of reference where Newton's laws are valid. Inertial frame of reference. In his frame, Newton's laws are valid. Newton's laws are valid. In this frame, Newton's laws are valid. Okay, let me ask him, this observer who is at rest with respect to the ground. It is the inertial frame of reference, and the observer is in the inertial frame of reference. And in inertial frame of reference, in this frame, Newton's laws are valid. Let me ask him what are the forces acting on this object. For this person, this object is moving in a circle of radius r. It is moving in a circle of radius r. When this cylinder is rotating, object on it is also rotating in a circle for a person outside. But for the cylinder, it's at rest. But for person outside, it is moving in a circle of radius r. So, what are the forces according to this observer? The forces observed. Forces observed. A, W is equal to mg weight. It is weight mg here. This mg will accelerate it downwards, but it does not accelerate downwards. Therefore, there is a normal reaction by this surface upwards. Normal reaction. So B is a normal reaction. N is normal reaction. Third, it is moving in a circle. So if it is moving a circle for this, that means there is a force, centripetal force, Fc, toward the center of the circle. That centripetal force is mr omega square, which you call as mv square by r, because v is equal to r omega, that this and this is the same, mv square by r. It is a centripetal force toward the center, because it moves in a circle. And for a person outside, when it moves in a circle, there must be a force toward the center. How much force must be there? Mv square r. But this force must be provided by a real agent. The real agent is frictional force, F. So this is also equal to frictional force. Frictional force. So for a person outside, the object in the cabin is moving in a circle. For him, there are forces. One is downwards weight, normal reaction up, and there is also force towards the center. And that force makes it to move in a circle, and that force is mr omega square or mv square by r. That is what an observer outside the cabin observes. And the net force is only this frictional force is equal to mr omega square. These two forces cancel off and cancels mg. Why? Because there is no vertical acceleration for a person outside. There is only acceleration towards the center of this cabin. That's all. This is the observation. He observes, he says there is these many forces. There is downward force weight, there is upward force normal reaction. The object moves in a circle for him outside, and therefore there must be a force towards the center. How much force must be towards the center? mr omega square for circular motion, and that force must be provided by a real agent, and their real agent is frictional force, because this sticks to this base, and that provides the frictional force, and it moves in a circle. That is all. There is no point, there is no question, there is no mention of centrifugal force so far, because this person will not observe, will not say there is any additional force. And all these forces are real forces, real agents. This is caused by gravitation, real. This is caused by the normal reaction base of this cabin. This frictional force is created by the contact between the object and the surface. So these are real agents. So all these forces are real. All these forces are real, means they have real agents. That is all. Now let me do something else. This was point number 1. It must be clear to you what it means for this observer who is at rest, who is on the ground, who is inertial frame of reference. He applies Newton's laws. If I ask you what is the acceleration, that acceleration should be net force, that is F by m, that is m r omega square by m, that is r omega square. So a particle moving in a circle has an acceleration of r omega square towards the center. Net force by mass. Net force is this. You divide by mass, this is r omega square. Okay, now let me go to the point number 2, so that things are very, very clear to you. Second, again I will take the same cylinder. It rotates with angular velocity omega. The cylinder rotates with angular velocity omega. And omega, you must know, omega is 2 pi by t, or omega is equal to d theta by dt, because it rotates with angular velocity omega. Okay, again I have to put an object here, so that, okay, let me put it here, but let me make a single line so that it is clear that object is on that line, like this. Object is again here. Now there's a person not here, there's a person here in the rotating frame of reference itself. It sticks to the ground. It is also rotating, this is also rotating, and the cabin is whole rotating. I ask this person, what is the acceleration of this object? He says 0, because it is rotating with him. So non-inertial rotating frame, non-inertial frame of reference. Inertial frame of reference. Rotating frame. It is also non-inertial frame. Rotating frames of reference also non-inertial frame of reference, because they are accelerating towards this axis. Okay, I asked this person, what's the net force, what's the net acceleration on this object? He says it is not accelerating. Actually, for a person outside, both are accelerating. But if I ask this person, what is the acceleration of this object? It says this is within the cabin, because within the cabin, every object is at rest with respect to each other. So he says its acceleration is 0. For a person outside, it is moving in a circle, but for him, it is not moving in a circle. It is in front of him. He says that its acceleration is 0. So first of all, he says net acceleration of the object is 0. The first answer he gives, that net acceleration of that object is 0. B, if I ask him what's the net force on it, again he says 0, because if net acceleration for him is 0, the net force also for him is 0. He says net acceleration of this object is 0. Also he says net force is 0. C, but what are the individual forces which make the net force 0? It is the net force which is 0, but there are so many forces acting. So he will say the real forces are there for him also. He will say all the forces which are real are there. So he will say mg is, he will weight wmg is the force for him. D, he will say normal reaction also. Normal reaction, that is this. He will say frictional force, yes. frictional force towards the center O. So these are real forces. So for real forces, there is no dispute between an observer outside as an inertial frame of reference and between a person inside the cabin. There's no difference. Real is real. Real is real for every person, outside and inside. But inside, see here, now comes something. If you find the resultant of these three forces, there will be a result. This will cancel with this because there is no vertical acceleration. So n is equal to mg for him. For him, n is equal to mg. So the net force is F, but net force is 0 for him because the object lies in front of him. The object is not accelerating with respect to him inside the cabin. For him, acceleration is 0. But now, if there are only these three forces, then there's a net force. So, what does he say? He says there is because it is rotating with omega. So this person is himself accelerating towards the axis. He says there is a force mr omega square away from the axis. Away from the axis, there is this force. This force is in addition to these three forces, and this force is only observed by this person. So the E force, additional force, F centrifugal is equal to mr omega square. So this person says there is an additional force away from the axis on the object, that is mr omega square. So when the object is rotating like this, for a person inside, there is a force away from the axis for him. So this what should be this now equal to? So this force should be equal to frictional force, so that the net force on the object is 0 for him. If he will not create this force, then there is a net force, but he feels the net force is 0. So therefore this is equal to this and this is equal to this. So he writes F point is, that means F, this frictional force is equal to mr omega square. That is all. So both will write the same equation for frictional force. Outsider says F is equal to mr square. Inside also says F is equal to mr square. But for this person, there is a centrifugal force acting away from the axis. And for a person outside, this particle moves in a circle. And for that, F is needed, which provides mr square, that is centripetal force. So for a person outside, there is centripetal force needed. For a person inside, centripetal force is not needed because the body does not move in a circle. Centrifugal force is needed for the body to have 0 acceleration. So for a person inside, there is a force which is acting away from the axis, that is mr omega square. This force is only for this person. This force is not for a person who is outside in the inertial frame of reference. That's all. So you remember these things. For a person inside, there are 3 real forces. In addition to 3 real forces, there is one more additional force, mr omega square. That is a consequence of a rotating frame of reference. That is all. So next lecture, what I will do, I will put this object outside, and I will make the observation from here and from here. Let me see what happens there. So again, I ask the students to download my app, Nazir Tantray Physics classes, and also subscribe to my channel so that you get all the lectures well in time. Thank you.